Today we'll be doing some work with regular expressions, or regex. And if you aren't familiar, regex is an awesome tool for you to be able to track down information across whatever data that you might be looking at. It's pattern matching to find text. You can think of it really simply as like Control F, but with a heck of a lot more power to find and search and even replace any info you'd like. So I'm on my Kali Linux virtual machine, and for us to be able to play with this, I'm going to open up a terminal with Control-Alt-T, F11 to full screen, and I'm going to move into a directory that I have for us called regex redact. And I have this super simple file here, info.md or info.txt, and I can open that up in a text editor. I'll use Sublime Text, and this includes just some sample fake data for us to try and search through or do some regular expressions work. Now I want to use this example because you might readily think of regular expressions or regex used for hacking, and that's really still what it is. Awesome, incredible tool for computer science, for technology, for cybersecurity, ethical hacking, penetration testing, bug bounty, but to have a little bit of a practical example here for us, I wanted to use regular expressions and pattern matching to be able to more redact or obscure some sensitive information that might, be in your reports. For work that you might do, or for anything that you're up against, I think redacting and trying to remove private sensitive information is still one awesome way to use and put to use regular expressions. I did want to give you a heads up, though, on Hacking Hub, hackinghub.io, where you can learn a little bit more ethical hacking, penetration testing, bug bounty, and a whole lot of sweet hubs or exercises where you can learn, and even some courses to get some more hands-on material with all of this work. They just released their regular expressions or regex for hackers course. There's a ton of other awesome, sweet stuff on Hacking Hub, but if we were to zoom in on the regex for hackers material, this whole thing is put together by Namsek, Ben Sadeghipour, and Adam Langley, Build Hack Secure, talking about how you can use regular expressions to bypass filters, spot vulnerabilities, and bring regex and pattern matching to real-world hacking. And the best part is all of the hands-on challenge labs, all the practical application-based learning so that you can actually build patterns and solve real problems. Whether you're beating up server-side request forgery, cross-origin resource sharing, working in recon, working in OSINT, all the awesome stuff that you might dig into for bug bounty hunters, penetration testers, and red teamers. Look, if you're interested, there is a link in the video description that will include the voucher that you could apply. It'll automatically be included in the link below. Or you could manually go ahead and enter JHRegex, and that will take about 50% off, so you can get this thing pretty easy, just $25. Big shout out, good stuff, Hacking Hub, link below in the video description. So all of this is fake data, right? Not my real email, not my real date of birth or phone number or card number or all this. But this is what we could get started with as just a small, simple activity to test and learn some regular expressions. And I think it would be awesome if we could build out a tool that will do this regular expression, pattern matching, and redaction in mass. Like, why not have something that could rip through all the files in a folder for whatever data you're up against, or just have something that could read through a file and then clean up, redact, and obscure the data that shouldn't be publicly shared. I've had to do this quite a bit, and look, I think, hey, it'd be fun to maybe work with Python, maybe script some of this. So I'm here at the documentation page for the RE module in Python to work with regular expressions. We'll go ahead and write some Python code so we could build out a tool to try and redact or obscure or make private some of the sensitive information in our info.md or .text or .log or whatever you want in your sake. I'm going to link the documentation in the video description because I think this is super duper helpful as a reference if you just aren't familiar with a lot of the different things regex can do. Because even that includes sort of a little library as to what all the syntax or the special characters inside of regex really mean. Because when we're used to using something like Control F or the hotkey to search for something in a document, you're used to just searching for the literal string. Like if I wanted to go find my email address, john.hammond@fake or whatever. But what if I wanted to redact not just my email, but everyone's email in a giant pile of data, like a breach report even? Same thing for date of birth, for phone numbers, for card information, blah, blah, blah. There's a lot of variety there, so we'll use regular expressions to find all that in mass. The thing about regular expressions, though, is that it normally ends up considering regular, usual, or ordinary characters and ordinary text as a literal value. Like ordinary characters of the letter A, uppercase A, lowercase a, or 0, they're the simplest regular expressions. They just match what they are, like the letter A, number 0, whatever. Think of that as like the regular Control F or find functionality that you're used to. But regular expressions amps that up with some special characters. That affects how regular expressions or the pattern that you're searching for could be interpreted. Like you could repeat any certain kind of character. Or you could match anything, any kind of thing, or the position, like the beginning of a line or the end of a line where some data or info could be. I'll walk through a good many of these special characters while we get to use our practical example, but again, if you want to learn more, I'll leave a link to this in the video description and how that could be used within Python. So let's go ahead and get started with our own regex redact.py or Python script, and I'll use a shebang line as usual, user bin environment python 3, and let's import that built-in RE or regular expressions module. And to make this more of a sweet utility for us, let's go ahead and import argparse so we have an argument parser, and we could just simply provide our info.md or any other file that we want to work through. Let's define the argument parser object as a parser, and then let's go ahead and add some arguments for us to work with. Add argument. Let's use the input that we want. That's fine as just a positional parameter, and then let's go ahead and parse our args from our parser object and store that in the args variable that we could now work with. With that set for us, let's try and open up like the file contents of our args.inputs. Realistically, that probably could have been named better as like a file or file path. And let's read the contents and we can store that as a variable contents. How about that? So let's get back to our terminal, and since we added the shebang line, we can add the executable bit to our regex redact script. So rather than needing to run it just with Python as the prepending command, we could just / or actually execute the script. With that, it will ask for our input, and we could provide our info.md file. Now it will display all of the contents because it has read that in the script. But now we got to do the actual regular expressions part. So now let's get back to our script, remove our print line, and let's start to define some patterns, or regular expression patterns, and actually regular expression objects that Python will be able to use to search for data or search for that pattern in whatever we're looking at. Before we do, though, honestly, let's play a little bit with the info and the data that we have. Because Sublime Text, the text editor that I'm working in, when I use Control F or Control H for even find and replace, while we search for whatever we want down below, I can also toggle on regex or regular expressions mode. Let me click that dot star, and you might be familiar with that because the dot in a regular expressions matches anything. A special character to represent any other kind of character. Let me go ahead and click the Find All button down on the bottom right. Obviously, this now has everything selected, and you can see I even have multiple cursors because Sublime Text is nice and convenient and lets that happen. But we've only matched one character, we just have multiple matches over and over and over again. A match of every single character. But realistically, I want to be able to match everything in one go, right? If that's where the example of like a dot star, like you might have seen just down below when we use the dot and this icon to refer to regular expressions, the dot asterisk is now working line by line. Let me click Find All, and you can see all that. Now they aren't all these vertical bars because we're not matching one character at a time, but now line by line, we're matching the entire length of the string. And that, when we use that dot star, the star or the asterisk by default is greedy. And what that means is that it's going to try to get multiple repetitions of the previous character, and we use the dot or the special character to mean anything, and it's going to get as many of them as it possibly can. The star actually means 0 or more of the previous character, but another special character for the plus symbol kind of does the same thing. Oh, repeating it indefinitely as possible to match as much as it can, but that is 1 or more of the previous character. Again, greedy, but if I were to add another special character here, like a question mark, I know this is weird, that makes it lazy. or non-greedy. It's not going to try to capture everything for as much as it can in one match. Once again, you see all those sort of columns or boxes where we've only got just one character returned in multiple matches. Maybe that doesn't make sense, so let's get back to our Python code so you can see that in action. Let me define a simple, silly everything RE, or everything regular expression, where we'll use an R prefix for a raw string in Python, and I'll move my face again. When an R is the preceding character before single quotes or double quotes in Python, it'll naturally, literally interpret the raw contents of the string. You normally see that used with regular expressions. So let me search for a dot, just as we have previously, but now let's go ahead and compile that everything RE pattern. Realistically, it's probably smarter to actually use the RE compile function around our regular expressions pattern. So then this everything underscore RE object is something that we could then start to match and work with things on. Let me zoom out a little bit when we have the contents data now defined, and let's try and print our everything.re.match to find regular expression matches based off of the data that we want to work with. Wrapped inside the parentheses as the argument to work with, let's use the contents that we've just read in from that file. Now, if I were to run this back in my terminal, I know this will probably look kind of silly and stupid, but we could just use that single dot character now in an automated way with our script and our code to get one match object. The very beginning of the file, just the character J. And that's all it returned because regex by default will give us the first occurrence of a match. And there's another function you could use. You could use something like search. And if I were to go run this again, you'll get the exact same result. But there's some nuance there. We'll talk about that as we get into other lines that we're going to be processing, but obviously this is getting just the absolute beginning of the data. What's to stop us, though, from using another function included in the regular expression library and these regular expression compiled pattern objects, one that's called findAll. That's not going to return a match object like a type that's available within and because of this library. It's actually going to return a big long list of all of the matches. And since we've only matched a single character or a dot, it's getting us a single character of everything. But what if we were to add in our special characters like the dot star or the dot plus? Remember, the dot star was 0 or more of the previous character, plus is 1 or more of the previous character. So let's try to run that. Okay. Now this is retrieving all of the lines using that findAll function. But if we were to switch that to go back to match or search, and we'll talk about the difference between the two of them in just a moment, but that's only going to return match being just John, or the very first line, even including the space at the very end. So let's look back at the documentation here. So there's a section here called module contents that outlines and lists all the different sort of variables, all the different sort of flags, properties, functions, and methods and things you can do with the built-in RE module. But the functions here are worthwhile for us to explore because we just use that re.compile. Remember, that's how we built out sort of our regular expression object, which we could then use the match and search and other methods that we've seen. We passed in a pattern, and then it was able to build this out. You could just as easily use the re.search and re.match patterns and functions like at the top level of the library, but usually it's recommended to just compile the regular expressions pattern matching object first because it's better, it's faster. It's more clean and you can do a little bit more, and that way you can reuse a pattern if you need to, rather than just passing it in alongside the string that you're working with these other functions. There's full match, there's split, they give us a couple examples here. Here's our findAll again. And let me get to, once we have a compiled object, we'll actually be able to work with those functions, like we saw with our regular expression objects. We could retrieve out of it the pattern itself, like the one that was used by and within re.compile, and we could search, just like we have. The distinction here, though, is that .search and .match are both going to return a corresponding match object. We'll explore that in just a moment, But search looks through the entire string or a line of text, just like we've seen, because it works line by line here. And that's probably what you're most used to when you're thinking of, oh, Control F or just naturally searching for something, right? But the match function that you might normally think of because, oh, you're getting a match object back has a little nuance. It's searching at the beginning of a string, the absolute start. So here the example they show, if you were to compile just a pattern to look for the letter O, and then you match it against the word dog as, okay, the data you're looking through, it's actually not going to find it. It's not going to return a match because O is not at the very beginning. Letter D is. But if you were to provide a position, just following, okay, one character into the string dog, then we start here, and we can go find O at the very beginning. Take a look at those other arguments. You can include the position or end position whenever you want to look for a match with either search or match, or full match, or find all, and all the other functions that we could call here. Anyway, I didn't want to belittle that too much, but I did want to make sure that was clear to you. There is a distinction between the search and match function, and they call this out even with some of the others. Match checks only the beginning of the string, while search matches anywhere in the string, and that's probably what you might expect or are used to when trying to Control F, search for something, or pattern match with any data. But remember, our objective here is to actually replace or redact some of the sensitive and private details here. So let's start small. Let's look for a date of birth. How about that? And while we could just search for the literal characters 1983, 07, 12, or whatever, that isn't really going to be all that useful if there's more data. We want to look for anything that looks like a year or month or date pattern. Now this has some nuance, right? Because you got to keep in mind, what if the data were to look like month, date, year, and be in a different format? You kind of have to have that understanding or know a little bit of what the data is going to look like, or try to build out all those different possible edge cases. For the moment, let's keep it easy. Let's start with just what we know we're going to see with maybe a hyphen or a forward slash for any of these representations. But we could make that sort of delimiter character totally optional, or have Regex still be able to figure out, okay, I'll match both or either one of those. The way that we look for those numbers, though, is by using some of these special characters. And we can assume, okay, it's going to be maybe 4 digits for a full year, or maybe 1 digit or 2 digits for any month or date. So we can use some repetition that uses these curly brace characters. Could be something that is exactly however occurrences or repetitions of the previous character, or a min-max sort of bounds, like, oh, maybe just 1 day, like October 7th, or 2 days, like October 17th, right? And the question mark, again, might be an option to make that non-greedy, so whenever possible, it'll get the least number of repetitions, or the max when we use a plus sign. But how could we search for these numbers, for one thing? Well, you could use some square braces. That's one option. The square braces will indicate a set of characters, or like anything that you want to be able to look for. You could just list out A, M, K as an example they use here, or you could use a range from like 0 to 5, or 0 to 9, or A through F, all uppercase, A through F lowercase, and anything that you might be looking for. While you could do all of that within the square braces, there are some other options if we were to use like a backslash character. I'm going to skip over some of the grouping information because we're just going to replace that, and I do want to let you explore that within the course. But you could use maybe \D as a special symbol to indicate, look, I want any decimal digit. That also includes the 0 through 9 set within square braces. When you see that \D for like digits you can think of, there's also \S for sort of spaces or white space characters like new lines or the space character or a tab character. There's even \W to look for word characters, maybe or letters. That does match some digits as well though, alphanumeric, and even includes the underscore, so you should know what you're using when you reference those. But I bring that to your attention because each of those as their representations has an inverse opportunity. Like if you were to look for digits with \D, you could just as easily find anything that's not a digit with \uppercase or capital D. that uses the same sort of set with the square braces we just discussed, but it adds essentially a caret inside of the square braces. And that is another special nuance. Outside of square braces, the caret should refer to the beginning of a line, but if it's the first character inside of a square brace set, that means not any of the characters that are included here. Let me go find that. Here it is, back in that section. If that includes the vertical caret up at the beginning of the square braces, all the characters that are not in that set will be matched. That doesn't matter to us too much though. Now we've got a little bit of the special sauce to be able to track down not just 1983 or 1 year, but any year, right? Or even any sort of number. Let's use the \D. There you go. You can see that's noting all these digits. And maybe we could use the square brace set for like 0 through 5. Take a look. Numbers like 9 and 8, obviously anything above 5 is not going to be matched. But if we did this 0 through 9, and then we were to match the curly braces to denote a repeat amount of occurrences while we're noting only any digit is the first character we're looking at, let's expand that out to just maybe 2 occurrences of it, or 3, or 4. Nice. Okay, so we are capturing the year, but now we're also capturing some other nonsense in a phone number or a credit card or something in a UUID. So let's try and clean that up. Let's search for, literally for the moment, remember a literal character, that hyphen or the dash, also still getting caught in our UUID, but we got to make sure we'll get the rest of our date of birth. Well, remember, we could use 0 through 9 or \D. Either of those two will work. Oftentimes, it might be more efficient for you to use the set here. You might just find some difficulty in other engines that don't use that quite as well. But now let's try to get the group of that or match the repetitions that could be either 1 character in length or 2. Well, because we have a minimum here, we're still getting the UUID that starts with the 4 after the hyphen, but we haven't quite finished getting the rest of the date of birth. Well, we could just duplicate the process that we have here to go find or determine that one. Now, even if I were to change this to be, oh, I was born on the 7th of the date, that still makes sense. If we were to use a date that doesn't make sense, like, oh, I was born on the 123rd day, well, that's not going to be captured. So now we have one example regular expression that we could use, even though very simple, that will work to maybe redact our date of birth. So let's build out in our script how we could kind of clean that up. Let's prepare a big list of patterns, and actually, let me define it as a dictionary. That way I could say the date is actually going to map to a regular expression compiled object of R for our raw string with our pattern included there. Now I have a reference that I could use to say, okay, the key for our date is going to refer to this regular expression pattern. So later on, I can really easily loop through all the patterns that we're up against and then appropriately replace whatever we want to redact, right? Question is, how do we get this to actually put in the redaction? Well, you might have seen it as we were scrolling along. We could use a function called sub. Think of that as like substitute, right? Here it is at the top level where we're working with a pattern. Since we're using a regular expression compiled object, we wouldn't need to provide the pattern. That's already all included. In fact, let's go find the sub function call that is used for a object. And this says it returns the string obtained by replacing the leftmost non-overlapping occurrence of the pattern in the string by replacement REPL. Okay, to replace, right? What we'll be replacing it with. If the pattern isn't found, then the string is returned unchanged. Okay, so that should be pretty easy to use with what we're working with, right? Let's try to actually loop through all of our patterns, knowing that we'll eventually add more for the other types of info that we're going to redact. Let's say for every redaction key and redaction pattern, in the patterns that we're going to work with, let's go ahead and replace the contents with that. Since the redaction pattern is already a compiled object, we can go ahead and simply sub replacing or substituting whatever it found with maybe a little format string where we could say redacted and then the redaction key. So it knows what exactly it was trying to redact, and we have some more context for that. And of course, we'll be replacing it across all of the contents. And we can clean this up a little bit, add some more white space so that's clear and easier to read. Now we've got a sweet little tiny engine that will go ahead and do the replacement or redaction no matter what patterns that we provide. So could I now print out or display the contents after we've gone through that first round of redaction? Oh, but before I do want to actually loop through all of the items in this case. That way we'll smartly get both the key and the pattern out of the dictionary that we've defined up above. Oh, and let's also add a space there just so the redacted bit is a little bit more clean. We can add even a couple more square braces. Now let's get back to our terminal and let me run our regex redact on our info document, and it has properly redacted the date of birth. Simple and easy, right? Regex put to work. Now we could build out any patterns that we want for the rest of the things we want to try and redact. We've got digits and math pretty well figured out, but we actually sort of skipped over one of the possibilities, like I was alluding to, if this were using forward slashes or another representation of the date. Well, we could just use another set, right, within the square braces here instead of the hyphen. Maybe that is a hyphen, or inside of this square brace set here, a forward slash. Let's try to work with that. Another option for an optional or either or characters could very well be, maybe if you had a longer delimiter or a change here, is actually using different parentheses. But then when you don't add some extra little syntactic sugar, that becomes a group, and it will be captured in some other part you can extract out of a pattern. We won't get into all that in this video, but just note those parentheses will get certain groups or parts and pieces of what you pattern extract. Inside this though, we could have a full word and then use a vertical bar to end up splitting one or the other. Will all be matched for that part or piece. So we could just as easily use a hyphen or forward slash and just make that an option included in there. That should still work, both with our square brace set and the optional group end here. Let's try that out again in our terminal. Let me clear the screen, run this once again. That has properly redacted the date, even when we're using now forward slashes for the date. Let's stick with one though. Let's just use the square brace set. Now it should be pretty easy though to go ahead and play with what we might find for phone numbers. This is interesting though because we have a plus sign, which as you know is supposed to be a special character in regular expressions, so we'll have to escape it out. And we just use a backslash to get that done. We might have an optional character though. What if there is no space here, or what if they don't have a break with a delimiter of like a dot or a hyphen? Well, we can mark any sort of character as optional by adding another question mark in there. Remember, that's sort of like that lazy operator or non-greedy. You can also think of it as, should this be here or not? So let's try to go find our phone number, looking for a literal plus sign. Remember, we're using the forward slash to escape that in regular expressions. And it might have a digit, one or more, right? So we could use our 0 through 9, and then the plus for the area code. And then the space could be there, or it could not be. So let's just literally add a space character, but let's make it optional with that question mark just following it. Then we chunk up what might be in a phone number. In different regions might have different pieces of a phone number. So again, you could map that to however many characters, however many digits you're expecting, with the repetition that we've seen previously with the curly braces. I'm expecting to see 3, but you could modify that, as you know, for min, max, other opportunities. And then we could have a set of maybe a period, maybe a hyphen, maybe any other delimiter, or, question mark, maybe that's not even there. It's optional. And then we can do this again for the next chunk of numbers, and then another that's actually going to be 4 characters to get that full phone number. Okay. At least just experimenting, that seems to give us a fine phone number pattern. So let's add that in to our capability of our script. Let's say phone number can be a compiled regular expression object with our R for a raw string. Paste all of this in. And now let's try to run our script. Nice and easy. Redacted phone number. Easy. But that is flexible. Like if this were to just now not use any of those delimiters and we're just this big long string here, running it again, not even making any changes to our script, still redacts it just fine. You get the gist? We could probably just as easily carve out one for a credit card, one for a MAC address, and let's try and bang those out here. You might find yourself, though, thinking, could we do even more validation, though? Like a credit card number is probably going to follow suit with a specific format or the representation of the numbers in like the LUN or LUHN algorithm. So you might have to build in more extraneous logic that isn't strictly tied to regular expressions to be able to carve that out, but still stuff to get you thinking about, what else should we be doing in like a big utility that we might really genuinely want to use for all this mass redaction? Let's get our device MAC. That could be 0 through 9 or an A through F or maybe lowercase a through F for like hexadecimal. And that's probably going to be in chunks of 2. It's probably going to have a colon here and we could fan that out to get the rest of it. Simple and easy, but this will work for us getting just a little prototype and learning a little bit of the regular expressions here. That works great. Redacted credit card number and redacted MAC address. I'll get a UUID for us done just as well. Those are likely going to be lowercase hexadecimal values, and I think the pattern here is 8 characters in length, 4, 4, 4, and then 12 at the very end. But you might make your regular expression even more sturdy. Try to add more capability just in case the data is represented in any other sort of different way. For our learning, though, I think this will work. And to be honest, you could make this better. I'm probably not using, the most absolutely perfect, genius regular expression pattern, but this is getting the job done. If you got a better way to go about some of these, please do let me know in the comments. I know especially, for a lot of this that is repeated, maybe we could even repeat some of those repeat potential. But let's get to one example that might let us be a little bit more clever in how we could validate even an IP address with regular expressions. You might be able to think, that's just 4 octets, right? They're all just 3 digits of numbers, or 0 to 3 or 1 to 3, right? In that curly brace range that we could duplicate for 4 different parts. But remember, an IP address for IP version 4 is probably only going to go up to about 255. So I don't want this to gobble up and get everything if it's beyond that range. So how could we do that and capture that even in just text? Well, what if we tried to set bounds as to what might be in or an IP address? Let me Control F again so we can start to build this out. Let's say we had some groups where parts of this are optional, right? Because if an IP address is about maybe 255 or 240, like 0 through 9 as the potential up to there before breaking into the 2.5 segment of the max value of an IP address octet, 240, then the first position could be anything up to a number 2, right? Like that could be a 100, maybe a 199 if we get to that. And then for something that doesn't even have a 100th position or 100th place, just 42 or like 1, we want to be able to match those. So with this as an example, could we match maybe in a group, probably the maximum position could be up to 255, meaning that the absolute max that could be inside of a group is 0 to 5. That would get matched. I don't want anything else other than that though, but that should be or 2 in the beginning or the very first 100th place of that up to 0 to 4, and then 0 through 9 for the next place or position, or maybe a 1 or a 0 in some cases, right? So let me do 0 and 1 and make that optional. And then any other digits, 0 through 9, also optional because you might have something that's only in the tens rather than the hundreds. And then normally that's going to have a number alongside it, right? So that could smartly define within the bounds and range of an IP address up to 255. And then we could make sure we have a literal dot there. Now see how that's capturing these first 3 octets, but not the very last one. But don't forget, we're building out something to get the entire IP address, not just the chunks or parts and pieces, all the different octets. And we have left our 0 through 9 as sort of mandatory. That has to be there. There has to be some digit some way, somehow. So if we were to now fan out our 4 octets, there's going to be another that we capture, and another that we capture, and then one more that we capture without a following dot or period. Now, we're smartly capturing IP addresses, and that will capture our original IP address that we're working with. So let's go ahead and use this. Add that into our patterns to replace, and now we can redact our IP address. Running this, clean it up. Okay. Now our final boss. Granted, this is really the beginning of the file that we just kind of skipped over, but our email address is where maybe we could capture some parts and pieces of it. Honestly, we've got the smarts and the skills at this point. This should kind of be simple and easy for us, especially when we know, okay, we could use the word \W to search for anything, or we could make that alphanumeric, A through F, A through Z, A through Z, really. Sorry, I was so used to thinking of hex. And that could include 0 through 9, or digits in your email address just as well. And there are other special characters that could be included, and maybe that's a period or dot, which will have its literal meaning inside of these square braces, or it could have an underscore, or a plus sign, or a hyphen or dash, and there's going to be one or more of those values, right? Plus sign. Now with its special representation, special meaning not inside of the square braces when it used its literal meaning. And that will be up to an @ sign, right? Literal @ sign, and then anything that might follow for the domain. But that could get a lot of stuff. There's potential that could break even further or past an email address. So maybe we add a literal / to escape and get the literal representation of a dot, and then the top level domain like .com or .net or .org that follows. You might need to build out a whole long list of all the things that it could possibly be, because otherwise you might run into some other trouble when you're trying to think of short domains like .io or .in or whatever. You could make that A through Z or A through Z and then use a 2 and then a single comma, not defining a bound or maximum end of it. That might work a little bit better. And now we've got that email regular expression that we can use. We can go put that way up at the top, honestly, and call our pattern matching little redaction script. Basically call it done for this example. Of course, we could make this even bigger and better. We could add more capability. We could have this loop through a ton of different files. We could have this redact more info or add a little bit more context here and there. But for our learning, I think this works. Let me try to run our redaction script. It does it just fine. So that was a little bit of regular expressions with the RE module in Python. Granted, we didn't cover everything. I didn't even get a chance to touch on the flags or the configuration values that you might be able to set for the library, like .multiline or .all or ignore case and all that. But realistically, I do want you to actually take this even further. I think it'd be cool to apply this for ethical hacking, for bug bounty, for looking at how you might be able to take advantage of regular expressions to go track down things in specific targets. Whether you're doing SSRF, maybe some WAF or web application firewall evasion. If you're up for it, would totally suggest going and take a look at the new Regex for Hackers course on Hacking Hub. There's a link in the video description, and you can go ahead and apply the voucher. JHRegex will take 50% off, and you can go ahead and get that for a sweet $25. Thanks so much for watching, everybody. I hope you enjoyed this video. Please do all those YouTube algorithm things, like, comment, subscribe, and I'll see you in the next video.